All right, in this section's SageMath video, we're going to go over something that we did in class. Namely, we looked at these interesting subsets of C that were obtained by taking the integers and then adjoining an element. So one of the subsets we looked at was when you take the integers and you add in the complex number I to form the Gaussian integers. So we're going to go over how you might define that ring in Sage and how you play with elements. And that's all we'll do for this one. So what we have to do is we sort of have to first create I. So we're going to start. We're just going to follow the documentation for this video. We're going to start by saying x is going to be a variable for us. It's going to be um, some some variable for a polynomial ring. And then we're going to do a weird thing that we'll get to at the very end of class this semester. We're going to say, all right, I want k dot a to be a number field. And what this is doing is it's saying, in fact, we're not going to call it a, we're going to call it image. What this is doing is saying, hey, we're going to create this object. It's going to be a field, and it's going to be obtained by adding in something called image, and image is the solution to x squared plus 1. Now we know that I is one of the solutions to x squared plus 1, so we're adding that in, but we're creating a number field. So what this does is it looks at Q, which is sort of the field that's related to Z. We haven't gone over exactly the process for how they're related, but from Z, the field that you create normally, the field that you create from Z is Q in a very controlled way that we'll talk about maybe if we have time at the end of the semester. Nevertheless, it's going to create Q, and then they're going to add in I to Q because I is the solution to that. And then what we're going to do is we're going to say R is going to be K dot ring of integers. And I forget if I need the parentheses or not. Let's try to evaluate it. Okay, that's fine. Let's ask it for what R is. Okay, so this does some field operation, and then we're going to take the integers inside of that. All right, oh, cool. It even tells us Gaussian integers in the number field. The variable is image. Great. All right, so now let's define some elements. So image should be I, right? So what should happen if we square image? Well, we should get -1. Ho ho ho, -1. Cool. Let's see. What should happen if we take I to the fourth power? Well, I to the fourth power is 1. We should get 1. We do. Nailed it. All right, let's try some more complicated arithmetic. Let's do like, I don't know, 4 plus 3 times I, and G is -2 plus 6 times I, right? So if you sit there and you work it out, you'll get something like, let's see if I can do it in my head, -8 minus 18, -26, and then 24 minus 6 is 18. We should get something like -26 plus 18I. -26 plus 18, oh shoot, this should be image, sorry, image, plus 18 image. Great, cool. All right, and so that's how you might define the ring of integers and how, or the Gaussian integers, and how you might go about doing computations there. Now, you don't necessarily need to use x squared plus 1. You could have added something else, like what else did we do? We also did like square root 5. Let's do square root 2. So I'm going to say square root 2 is here. What polynomial equation does square root 2 solve? It solves x squared minus 2. And we're going to call it square root 2 this time. All right, so let's evaluate. Cool. So we get something similar. Let's actually just check that, let's call it let's just check that square root 2 squared, that element that we're adding on, that we're calling square root 2, actually is in fact 2. And it is. Awesome. So this gives you a way of doing this sort of this polynomial arithmetic in the ring of integers. Well, in these sorry, not polynomial arithmetic in these rings where you take the integers and you add in something. Technically, these are domains.